Hello, this is Princeton Cloud Analytics Meetup. So we focus on the cloud architecture, and we are the cloud enthusiasts from the town of Princeton, New Jersey, and the surrounding towns. So this is the second part of our December meeting. So in the first part we covered the basics of cloud computing, but in the second part we will be covering more interesting topics. What are the latest trends in the cloud computing? What is cloud native? Because the thing is, there's a historic way of doing computing. You had servers and you need to buy servers. So there's a historic way of doing things. Cloud native has changed all that. Because of cloud native, the totally new way of doing computing has emerged. One of them is function as a service, microservices. So Tony, who specializes in this area, he has his own company. So he'll introduce himself briefly, and then he will talk about cloud native.
Thank you, Omar. My name is Tony Vinayak, VP of Consulting at CloudNonstop, and we provide cloud services of all kinds to our customers, including cloud migration. We also provide monitoring services through our 24/7 NOC, as well as help companies to automate their DevOps pipeline. So back to the presentation, and then so one of the emerging trends that we do see in cloud computing is like this. So you heard about infrastructure as a service and platform as a service, and now we have this new emerging trend called the function as a service, which is greater degree of abstraction of platform as a service. You could say that. The major difference being that, so as the name suggests, so you will be building functions. Think of your application as multiple functions. That's how you architect it, and then you upload the functions into the cloud, and the cloud provider will deploy it for you, with the corresponding runtime. So you could be building your function in Node.js, Java, Python, .NET, and then so once you're deployed in the cloud, then the functions they are invoked. Event-driven architecture. So, and one of the major differences between function as a service and platform as a service is the fact that you only pay for the time when the functions are actually invoked. So at all other times, when the function they reside in the cloud, and if you're not using them, they're not being invoked, you're paying nothing. So as you can imagine, so that makes a tremendous difference to your billings. So, so that's the good thing about using functions. Now, function as a service is definitely part of the what's coming to be known as the cloud native applications. And here, we've highlighted some of the major trends that are there in the market right now. So, for example, breaking down, I should say, your legacy monolithic applications that might have been built over the years using Java, .NET, Visual Basic, so on and so forth.
Excuse me, Tony.
Yeah.
I just want to clarify just one thing that, as you mentioned, you need to know that you do not need a server anymore. Like previously, to run any software, you had to have a server.
Yeah, for the function as a service. Right?
Yes.
Yeah, that's
everything will be taken care by the service provider.
Correct.
You just code your code. You don't need a server, which means you don't have to manage your patches. You don't need your system admins.
Yeah.
Everything will be managed by the cloud provider. So that is a really big
yeah, and that's a big deal, as you can imagine.
Right.
So anyway, so in terms of the cloud, so what is a cloud native application? So there we think in terms of microservices. So these are the new application development pattern, and we'll talk a bit more about what is a microservice in the following slide. But the other things which are becoming popular is deploying those microservices not on the bare metal, not on the virtual machines, but in what is known as containers. And again, we'll talk a bit more about containers in the coming slides, what that means. Another popular term in the market these days is continuous delivery, which is fully automating your application delivery and deployment in production, and which is again part of DevOps principles. And DevOps is a combination of tools and processes that allow you to automate your software development and deployment, and we'll talk a bit more about that later on as well. And another interesting cultural shift that has emerged is instead of having a centralized governance in a large enterprise, so even if you have 10 different development teams in different parts of the world, So instead of worrying about enforcing development standards across all of those groups, so the new trend is let them choose their own technologies. Assuming they're using microservices architecture, I must add. And for example, at Amazon, they have like 30 different platforms, development platforms that they use as part of their microservices development effort, and they are perfectly okay with it.
I have a question for you.
Yeah.
Is in this microservices architecture, database is the common thread or no?
Good question, and I've got a slide that's going to talk a bit more about that as well. So, here's a little more information about microservices. So, as we all know very well, and all of us here, we've been around long enough. In the traditional approach, you have the presentation layer, you have the server-side logic, and then you have the database layer. In the microservices pattern, so that one is a little different. How, think of a human resources application, for example. So within that, then you start thinking in terms of what are the smaller components within that, that could be built independent of each other, right? So within that, there would be a payroll processing, there would be one for compensation, there would be another one for training and development and so on and so forth. And then within each one of those disciplines, again, think of further breaking it down into more, microservices. So these are the services built around the business capabilities. And why are we even thinking of doing microservices? Oops. The whole motivation behind them is that once we are able to architect the entire system as microservices, it makes them each one of those microservices independently deployable. That's a big deal, right? Because if you have a larger system and then every time you make a change to the larger system, you have to redeploy the entire system, rather than being able to deploy small components. And then, the larger the system, more the dependencies, and then you have to worry about the drivers and the runtimes and the database interfaces and the presentation, and you have to test the whole thing out.
Regression testing.
Exactly. So it's a lot more intricate, when it comes to developing and deploying larger monoliths. So divide and conquer. So, and it's not a new concept, right? So we've all, known object-oriented programming and service-oriented architecture. So this is probably a newer manifestation of similar kind of development patterns, and now known as microservices. Here's an example of that. So let's say you have a traditional monolithic application, plus all of its functionality, all of those they're running in a single process. And in case you need to scale it up, right? So you have multiple instances of the application that need to be deployed across multiple servers. Then you put a load balancer in front of it, and randomly allocate requests to it. That's how we do it today, right? So, so as you can tell, the scalability suffers because we are replicating the whole monolith across multiple servers, right? As compared to if you were to be building the application as microservices, and then each and every microservice can run in its own separate process or a separate service. Then, when it comes to scaling and distributing the services across multiple servers, so you can do that on an individual level. And the scalability is a lot better. So let's say you identify there's a bottlenecking in the initial order processing microservice. So that's the only one that will be scaled up horizontally, and not the other pieces, because they seem to be doing fine. So it lends itself a lot better to scalability, basically. And then this is, perhaps a little more academic, but normally when you talk about microservices, so this is again part of the cultural shift. Organization designs a system whose structure is a copy of the organization's communication structure. What it means is, typically, traditionally, we've all seen that, within a development shop, you will have, the UX or the UI specialists, right? So no matter what application needs to be built, so for the UI, you go to them, right? So they do the UI for all the applications. And likewise, you have the middleware specialists who know how to deploy the middleware, create the middleware functions, and so on and so forth. And then you have the DBA, right? So they take care of all database requests across all of the different applications. So that's how it has been, so far. And so that, the argument goes, leads to siloed application architectures. As compared to microservices, so where you organize the teams around the business capabilities. So What it means is, in case you're building an HR application, so you assemble a team just for HR, which will consist of the UI, the developers, and database team. They're only focusing on the HR, and likewise, you have a separate application for order processing. So you build a separate team, just for that, so that you have complete ownership on that particular application. So it's once you adopt microservices, it also brings about some cultural changes the way you develop applications. And this is again something we help our customers to get to that stage once they decide to adopt microservices as their architecture. And back to your question, Deepak, about databases. So one major difference there that emerges is in a microservices, typically you will have a single database server, right? And yeah, sure, within that you will have multiple tables and multiple partitions within the database. But typically you manage a central database, and this is where everything from all the application that flows into it. In microservices, and what's the fancy name is the polyglot persistence. Basically, each and every microservice has its own database. They don't even have to be the same database brand. So for one particular microservice, you might use a relational database. For another one, you need a graph database, and for another one, a NoSQL database probably makes more sense because that particular microservice is handling semi-structured data. So you pick and choose the database, whatever is the best, for that particular function of the
That's
microservice.
nice, but if you have dependencies, then you may want to join the data between two tables. Then that's not.
Yeah, and that's where when it comes to partitioning your application into microservices and make them decoupled. So that's again part of the microservices architecture. So each and every microservice is standalone, and it has no dependency with any other microservice. And all the state information that the microservice knows about is completely self-contained. It doesn't need the state information. It is not storing the state information in any other microservice. And then they talk to each other, using typically HTTP. That's it. So loosely coupled.
So I would like to give you two examples. So one is Amazon has designed everything using services. So that's why it's called Amazon Web Services. It's not monolithic. Every service is independent, and they can scale every service separately.
Yeah.
That's one. Second thing is they're providing some things for users to handle this easier way. For example, they're providing the HTTP gateway so that it handles your HTTP traffic, and there's a thing that's called Cognito, which is for your identity management. So when the user logs in, you don't even have to develop the software for user identity management. The Cognito will take care of it. So basically, you can just focus on your function, which is function as a service. So this is part of the microservices, but what Tony is explaining is the overall architecture. But it's not as difficult as it sounds, because some of the things is baked in by the vendors, like the HTTP gateway and the Cognito.
And thank you for mentioning HTTP gateway, because that one is actually referring to the API gateway.
Gateway. Yeah.
And this goes hand in hand with microservices. And for example, the reason being that once you start building an application as microservices, you could have dozens, if not hundreds, of microservices which are part of that application. And each and every microservice has its own API, has its own published interface. Right? These are my functions, this is how you're going to call those functions, and this is the data I'm going to return to you in response to those function invocations. So that can get very messy, right? So for example, if you have an online credit card application, you need to perform, as part of the application, you need to perform different kind of checks, right? Check for social security number verification, and address verification, anti-money laundering regulation, and credit check. And each and every step in turn could be multiple microservices, right? So if you need to build an application, so you need to know each one of those multiple microservices, and then you need a different UI for the desktop and the mobile devices. So your head will hurt, all the function invocation that you need to know for each one of those microservices. So that's where the API gateway comes in, and what it does is it consolidates API calls and it aggregates some of those functions. So at a high level abstraction. So if you simply want to do an SSN verification, the API gateway will publish an API and say, all right, I'll do it for you. And by the way, tell me who you are. Are you a desktop or are you a mobile? Because I will reformat the data as it comes back and give it to you the way you want it. So basically put an API gateway in front of the microservices. So that's one of the patterns. So
Hi, Tony. A quick question on when you have these microservices architecture, how does user context, entitlements, authentication flow between what is common? How do you utilize that?
Yeah, so the user context and everything goes back to the persistence, and so each and every microservice will be having its own persistence layer. So and so there's no so very loosely coupled basically. So every time you need to get some information out of a particular microservice, so let's say you pass in a customer ID, and then you want to get the credit score, for that particular customer. So that's how it works, right? So
you're asked, I think.
I'm talking about transactional systems.
So I can give an example. So like the NoSQL database like DynamoDB, you can, because the function is stateless, but the user communication you need a state. So you can use DynamoDB and keep your state there.
Oh, in the
Elastic cache.
in the cache basically, the cache.
Right.
But if they're using
Yeah.
different databases, as Tony was saying, then
Yeah.
somebody's using DynamoDB, somebody's using MySQL, somebody else is using MongoDB,
Yeah.
then that's not gonna come together.
Maybe I can answer. I don't know if I understood your question. So you're asking more about the authentication of the thing, or?
Right. For example, if you have a complex transactional system, can you engineer a
Oh, yes,
complex
yes,
Absolutely.
real-time transaction
Yes.
system
Yes.
as microservices architecture?
Oh, yes.
Absolutely.
Yes.
Yeah.
I mean, think
Yeah.
about even Amazon.com, right? So all what it has is all independent microservices, right? Even if you think about, I don't know what industries you guys work in, if you think about healthcare or any banking services, right? If you look at, if you want to access your credit card, or maybe if you want to access loan, or maybe if you want to talk to someone, they all act as a separate microservices. So maybe your question was, hey, how does that microservice know who the actual user is? I mean, there is a
So-
separate SAML and Active Directory kind
Yes.
of thing.
So I'll give an example. What happens is once it authenticates, it gives you a token because it doesn't want to carry your user ID. That token is a unique token, and then that
token can be
yeah
propagated.
you will use that token to link with all everything else for that call.
Yeah.
And it is active.
So we can discuss
But
the
it's
detail
obviously it's a
offline.
bigger discussion,
Yeah.
and
Yeah.
we can talk more
Yeah.
about that.
Yeah.
So yeah, quickly pros and cons. Microservices are easy to develop, and the whole big deal is that they can be developed and deployed independently. But that's the major motivation behind microservices. Improved for isolation, so that in case something is malfunctioning, so it does not have an impact upon the other microservices, and no long-term commitment to a technology stack, because they're loosely coupled. So each and every microservice can be built using any like I said, at Amazon they have 30 different development environment that they're using for building their microservices. Increased memory consumption because you have more microservices which are being invoked, and testing is not that easy now because you have to do testing across multiple microservices to make sure that nothing breaks. And then you have to implement the inter-service communication, like the word just started talking of, a token that needs to be propagated around, and aggregating the APIs and so on and so forth. And deployment may not be that easy because you have to deploy multiple microservices. So here's an example of just an e-commerce application built on microservice framework. So mobile app makes a REST API call to an API gateway, which in turn will talk to the account service and the inventory service and the shipping service. So if case they want to place an order, firstly it will go to the account service to retrieve the available credit for that particular customer, and then after that it will go to the inventory service to see whether or not the product is available, and if it is, it will place the order and send it out to the shipping microservice. So showing the API gateway here in this example, and also as an example showing that you don't have to use an API gateway, but it helps in a lot of scenarios. So this is like a browser-based application that's been shown here as well. So anyway, it's very high-level example of a microservice framework in action. And hey, it has wide adoption out there in the market. So Amazon, Netflix, Uber, eBay, they've all in on microservices in their application. All right, so DevOps. How much time do we have, Omar? So I can.
We've got 10 minutes.
Okay, very good. So now the other thing, another extremely popular trend when it comes to cloud computing is adopting the DevOps principles when it comes to application development and deployment. And DevOps, as you would know, it spans the entire spectrum of application development through to deployment and subsequent monitoring in production, right? So this slide actually shows you different phases of application development and deployment, some of the popular tools that are available for each one of those stages. For example, for automated testing, Selenium, that seems to be very popular these days. And for continuous integration, Jenkins is one of the more popular tools out there these days, and so on and so forth. So in deployment here, just to talk a bit more about that, and this is again, something new in the market and becoming very popular. So early on, what is a microservice? What is a cloud native application? So I made a brief mention of containers, right? So just to talk a little bit more about what is containerization. So here's the formal definition from Docker, which is the most popular container product out there at this point of time. And to put it, simplify the process even more, explanation even more. So we all know virtualization, which has been around for a long time. So you have the infrastructure and then the hypervisor, and then each and every VM has a complete copy of the operating system and the binaries and the application and so on and so forth. So on one server, if you have 10 VMs running, so each one of those VMs is going to have the entire stack on it. Now in containers, when you create a container, things get a little more interesting. So they figured out that, it's silly to have 10 different copies of the operating system running on the same server. So let's figure out a way to have only one copy of the operating system running, and then its kernel can be shared through this software called Docker. So that's a more popular one. With each one of these application runtimes. So now you can have 10 different applications packaged as containers running on the same server, and then there's the Docker layer running common across each one, all of those applications, all of those containers, and they're all sharing the same host OS. So a lot more efficient in terms of resource consumption. And the good thing about the containers...
What manages the shared resources on those?
The Docker layer.
Okay.
And then there is another layer actually called the container orchestration layer, which manages the networking and scalability.
So I like to give a very good, actually it's a very good example. The problem with traditionally auto-scale environment was, because the traditional was based on the elastic load balancer, like you get the load, and if you get matrices, like if you got more than 80%, you spin up a new server. But spinning up a new server takes time.
Yeah.
It can take between like 1 minute or 2 minutes. It could take a minute. And that, your user response is going to suffer for a minute.
Yeah.
So as compared to that, Docker is very lightweight.
Yeah.
It can spin like in a second.
Instantaneously, yeah.
User will not even feel, and the environment will auto scale up. So that is one of the biggest reasons to go with Docker. Is like to have seamless user experience. And if you want to go a step ahead of this, then just use a function. Because if you use a function like a Lambda function, Amazon will totally take care of scaling. You don't even have to manage to take care of your Docker.
Very true. Yeah, and basically, when it comes to a cloud native application, so think of, so you have your API gateway, and then you have your microservices, which are deployed within containers. And, and then in addition to that, there is this additional layer for container orchestration, because how are you going to provision the containers? Who's going to manage the the scaling of the containers, right?
Right.
So and the networking interaction that needs to happen. Who's going to set up the network between those containers and so on and so forth? So that's the additional layer of software that goes hand in hand with the containers. Docker have their own software called Docker Swarm and Docker Compose, and then there's Apache Mesos, open source. Amazon have their own called Amazon ECS. They just came out with something called Amazon EKS, which is Elastic Kubernetes Service. Then they also came out with something called Fargate, which is another layer of abstraction that they announced at the reInvent, where you don't even have to worry about the orchestration. They do everything for you, magic. Kubernetes is the one which is more popular in the market these days.
Excuse me, Tony, can you wrap up? We'd like to get a few minutes to you to talk about reinvent. So,
Yep.
so can you sum it up and
Yep.
maybe come here and speak a few minutes?
Very quick question. So those are all the orchestration services? Those are examples?
Yes,
of all
these
of
are
them?
these all of them. Each one of those is an
Okay.
orchestration service.
Okay, good.
And Swarm and Compose, they go hand in hand together.
Okay.
Then there is Kubernetes, and then there is a Mesos, and then there is, I don't know.
Excuse me, Tony, can you please wrap up?
I can stop anytime.
So,
Very good presentation, by the way.
Thank you very
Thank you,
much.
Tony.
Thank you.
This is very impromptu.
introduce yourself. So we are wrapping up. And before that, we've got a gentleman who just came back from Vegas, and
Okay.
so he would like to share his experience of reinvent.
Hey there. My name is Karthik. I am an engineer, architect by education and by profession, and I also have a small firm. Okay. So I've been to reInvent, and this is my third time being to reInvent. It's an awesome place to hang out for at least cloud enthusiasts, right? And Amazon has at least announced more than, quite a few good number of services this year. I don't remember the exact number, but quite a good number of services, basically in DevOps area, as you just said. And there are more Lambda, Lambda is a serverless function, right? That is now a HIPAA service, right? So which means before, this is a HIPAA service from quite some time, and they have enhanced some more features there, right?
So, Karthik, we just have like 2 to 3 minutes. Could you sum up your overall experience of reinvent?
So reInvent is one of those worldwide technology event by AWS, and you see about 40, 50, this time it was close to 40, 45,000 people came up there. So there are lots of workshops, there are lots of sessions. There are over 1,000 sessions you can attend. Big data, DevOps, you name it, serverless, AI, bots, and all that. So there are quite new number of services that got announced, and that's one good place to hang out. So now we are about 10 people here, but if you go there, it could be about 45,000 people.
Yeah,
right?
oh, amazing.
So they're all like-minded. There are more C-level officers. There are some company owners and everything. So it's a good place. If you guys are into that, usually the tickets would be around June or so. That's when they actually start selling it, and it would be close to about 1,800 people.
Could you tell us about something about keynote speeches? The keynote speeches at the reInvent. Could you talk a little about that?
There were a lot. Omar,
Andy.
it is quite
No, the main ones.
The main one, Andy
Yeah.
Jassy
Yeah.
has announced. Yeah, that's about 3-4 hours of session. So one of the sessions, one of the service they have announced is AWS Amazon DeepLens. So which is camera DeepLens, yeah.
DeepLens, yeah.
So what it is it's a camera which you can train and AI thing,
Image recognition
and all that. So that's quite an interesting thing. So I got my DeepLens.
Oh, you got it?
Yeah, I got my
So you'll be
DeepLens.
building some apps on it, I
So,
hope?
yeah, I'm working with my
Cool.
other engineers.
Yeah.
I'll get it here so someday. Yeah,
Good. Yeah.
once it is
Yeah.
here.
So someone coming in front of your house and...
And it can
will
do
tell
a
you,
lot
"Oh."
variety of things. And I've attended a workshop where I trained the DeepLens. They actually did a workshop where I trained my DeepLens to recognize between an object. It will identify whether it's a hot dog or not. So that kind of
Ooh, hot dogs.
Yeah. So those kind of things.
Okay, you have 1 minute. Could you just sum up about reinvent, about
See,
next steps?
It's about 5-day session, and it is impossible for me to just as an impromptu. I cannot just give you
Yeah, but
a summary of it. But again, as I told you, it's all about Amazon and the way they scaled up on the services. It is unimaginable, right? So it is one of the places. If your company is where you're working for, if the sponsor, you should go for it, right? And cloud, I believe Azure is picking up, right? It is a little lower on the scale, but Amazon is already there. I think Azure and Amazon, Google, I think they all make a very good place to learn about. Yeah, that's what I think. Yeah. Thanks, Omar.
Thank you.
And the other good thing is...
It's too impromptu, Omar. You should give me at least some kind of heads up. What's up?
That was the heads up. Come over.
I know you had so much time from day to year to
Yeah, exactly.
figure out what you want.